Hey folks, this is Captain Jones here talking about the LC3 Datapath Take 2. We know enough at this point to refine some stuff, and so we're going to put together a picture that will inform our understanding for the next unit or two. So we got two objectives today. Number one, we're going to complete that basic design of the LC3, and then to help solidify that, the second thing we're going to do is trace the execution of an instruction all the way through the processor. All right, so recall from our first introduction to this, the first take on the LC3 data path. This was kind of the model that we used. And, hopefully at this point, this is starting to look a little more familiar. Our updated version here at the end of chapter 5 looks exceedingly similar. If you take a look at these two side by side, the only differences are that you can see on the left here, I've got a couple of arrows that kind of aren't coming from somewhere in terms of the control unit. And on the right hand side, you can see that those are specified where those are coming from. But basically the rest of this is all the same. Okay, so what I want to do now is jump into OneNote to this one. No, not this. Okay, so that we can take a look at this a little closer and highlight the differences. So I'm not going to belabor the same points that I did last time, right? So at this point, hopefully, the fact that the program counter is its register and it has a tri-state buffer because it's talking to the processor bus is nothing new. What I will point out are these arrows are now filled out, right? So you can see here we've got a couple of values that are coming from our instruction register that are assigned extended and then sent to this address mux. So certain values out of our instruction register or potentially the value 0 that are being added to this is our program counter, and again this is this is a slight correction from before. So the value to this that goes to this register is not coming out of the incrementer here, but straight from the program counter. Or I could be adding these sign extended values to one of my registers, and then the output of that adder could be going to my program counter or it could be going to the memory address register mux. I got one more value here that's actually 0 extended, bits 7 to 8. I'll give you a little hint. That's coming from my trap instruction. We'll talk in Unit 3 kind of how that's executed. Just know that that's what that is for right now. The rest of this is basically the same. I get a couple of names here, address 2 mux, address 1 mux for my control signals. The rest of this is as it was before. The last change that I'll note is that the SR1, it's not shown here, actually comes from a multiplexer. And that's because there are two different places in our instruction where this value may come from. In some instructions, it's bits 11 to 9. I think in one instruction, it's bits 11 to 9. In most of the rest of them, it is bits 8 to 6. Okay, so there's a little control signal here that's not quite shown. That helps us pick the correct field in our instruction to select SR1. All right. Gosh, I think that's all I got. This is a quick one. Oh no, we're going to do this. That's right. Okay, so the last thing I'll say about this is, I think it's helpful for me to come at this from maybe two ends, right? To do maybe what we're about to do in a sec, which is to take each instruction and sort of trace through its execution through the LC3 to kind of see which pieces it's touching and which parts are being routed through which multiplexer and whatnot. The other thing that you might do is just kind of looking at this, ask yourself, okay, there's an instruction somewhere that has bits 10 to 0 that are sign extended to be added to something. So you might ask yourself, okay, which instruction uses this thing? Or slightly more difficult, which instructions use this adder here to kind of update the PC mux or the MAR mux. Those will help you understand kind of how each of these instructions is using the LC3. Okay, so what we're going to do now is follow along with the book as it traces the load register instruction. If I'm not mistaken, this is the instruction that's sort of walked through at the very end of chapter 5. I think the text does a good job, but there aren't any visuals, and I'm a visual person, so it's tough for me to kind of understand what the book's saying. So what I thought I'd do is change my display again and pull up the simulator, and hopefully we can sort of observe that instruction as it's being executed. Okay, so here's my simulator. I'm about to start executing the load register instruction. So I'm in the middle of this branch. I'm gonna click. Okay, so step one of effectively my load instruction. I'm gonna fetch. So program counter goes to memory address register. On the next clock cycle, the instruction for load register goes into the memory data register. And then on the third clock cycle, my fetch is complete and my instruction register has the value, in this case 62C0, which is the instruction for my load register. And forgive me, I've got a couple of different values from the book. Hopefully those don't affect your understanding of the load register instruction. Next is my decode phase. Okay, so that instruction register goes to my control unit, the finite state machine. And the next phase of my instruction cycle is to evaluate the address. And so if I click my clock cycle button, what I can see here is my address for my load register, recall, is I'm adding whatever values in my instruction, in the lower part of my instruction, to the value that's in R3. So you can see here, part of my instruction register, bits 5 to 0, gets sign extended, and then added to SR1, which we can imagine at this point, this is specifying register 3. Those values go through the memory address register MUX and into the memory address register. If I look at R3 is 300C, that plus 0 should be in the memory address register, which is right there. On the next step of my instruction cycle, I'm fetching operand. So I'm going to get something out of memory. I'm getting the piece of data at this address. So the data register gets loaded with the value that's in 300C. If I were to scroll down here in my instructions, I would see that in 300C is value 397. So memory data register has the value 397. And then on my store result phase, which is the last phase of my instruction cycle, the data register put that value hex 397 onto the data bus. That went all the way around into register, register 1. Register 1 has the value 397, and along the way, my condition codes got set in case maybe I'm going to try to branch based on the result of that. Okay. So if you need to see that one more time, rewind the video. And you know what I'm also going to do is change my display back. Okay. Okay, so today we talked about an updated LC3 Datapath. Predominantly, we just sort of filled in these arrows here in the control unit to show which stuff's going to which MUX. But additionally, we corrected this path from the program counter around to the address 1 MUX. And at least in my other notes, I annotated there's actually a multiplexer here that feeds source register 1. And you should all probably try to see if you can figure out which instruction that is. Go back to those notes to figure out which instruction needs to go back and forth between those two. And then we also looked at the simulator, and we walked through the execution of the load register instruction sort of step by step. All right, that's all I got, folks. I'll see you next time.